Hello my lovelies, I hope you are well. Let's talk about our lesson 4, talking about the types of bond, ionic bond, covalent bond, metallic bond. Let's start. Okay, let's start with the ionic bond. We talked about it at lesson 3, so let's make a revision. The ionic bond is a force that brings the opposite charge ion together, the metal with the positive charge and the non-metal with the negative charge, and then the ionic bond formed between the metals and non-metals. Also, in the process of the ionic bond, the valence electron moves from the outer shell of the metal to the non-metal. Now we'll talk about the ionic bond in 3-dimension pattern, called a crystal lattice. What is a crystal lattice? Each ion has many opposite charged ion around it, and every ion is held firmly in a place with a strong bond. So it takes place a lot of energy to separate this ion from one another. So the ionic compound have a high melting and boiling point due to the crystal lattice structure. And this is the shape of the crystal lattice structure of the sodium and chlorine ion. Let's continue. The crystal of the ionic compound are hard and brittle. Like we said, it have a high melting and boiling point. The striking crystal of the ionic bond with a hammer will likely shatter the crystal in many places. The solid ionic character are a poor conductor of electric current. It's a poor conductor of electricity because the ions are held tightly in a place. Melting an ionic solid, however, allow the individual ion to move around the metallic ion to conduct electric current. So the ionic compound dissolve in water and can also conduct an electric current. Let's take the second type of bond called the covalent bond. The covalent bond forms when the atom share one or more pairs of electrons. When the two non-metals bond have a large amount of energy is needed for either the atom to lose electrons, so they bond by sharing electrons. In a covalent bond, the shared electron fill empty space in the outer electron shell of each atom. The chlorine has a 7 valence electron and therefore need one more in order to fill the octet rule. The octet rule is that they both have 8 electrons in the outermost energy level. So we have two non-metals like the chlorine. They share together their electron to be 8 electrons in the outer shell. Let's continue. What is the molecule? The molecule is a substance that have a covalent bond made up of individual particles, like we said when we have two oxygen, two chlorine bonded together. The molecule is a group of atoms held together by the chemical bond and the smallest unit of the compound that can identify as that compound. In the water molecule, we have two hydrogen atoms form a covalent bond with the oxygen central atom. And then, what properties do most covalent bonds share? Some of the covalent bonds dissolve in water, and other covalent bonds can't dissolve in water, like the wax. The wax have a stronger attraction to other wax molecules than they have to the water molecules. This is why the wax doesn't dissolve in water. When the covalent bond melts or boils, the covalent bond holding the molecules together doesn't break as ionic in an ionic compound. Instead of one molecule separate from another, because the molecules separate easily from other molecules, they tend to have a lower melting and boiling point than the ionic bond. So the covalent bond have a lower melting and boiling point than the ionic bond. Most of the covalent bonds are poor conductor of electricity in both solid and liquid, unlike the ions which are charged. So even in the liquid in which the molecules can move around, the compound can't conduct electric current. So let's talk about the metallic bond. The metallic bond formed between the metal atom when their outermost energy level overlap. The melting bond is weak compared to the ionic or covalent bond. You can think of the metal as being a positive ion with enough valence around to hold ion. The copper melt is held by melting point to another copper. And also, because the electron in the metal can move, so most of the are conduct electric current. When you turn on the lamp, the valence electron moves through the copper wire that connects the light bulb to the electric outlet. And the valence electron in the copper atom are free to move because they aren't connected to any other atom. And also, the free-moving electron metal have two properties that allow them to be reshaped. The malleability is ability to be hammered into sheet. The ductility is ability to be formed into long thin wires. We finished this quarter, so if you need anything, please tell me.